So let's talk about something that's, well, it's everywhere, machine learning. But what does it even mean for a machine to learn? How does it actually work? That's what we're going to break down today.
I mean, really think about it. We launch a rover from Earth. It travels for months through the vacuum of space, and then it has to land itself on Mars. There's a 20-minute communication lag. That means no one on Earth is flying it with a joystick. It's all on its own. How in the world is that even possible?
Well, the answer, it's not magic. It's machine learning. And at its heart, machine learning is really just about one thing: letting a computer figure out how to solve problems by finding patterns in a whole lot of data.
Now, to really get how machines learn, we don't need to dive into a bunch of terrifying math. Nope. Instead, we're going to look at the kinds of problems they're designed to solve. Think of it like we're peeking inside their playbook. You see, machine learning isn't just one magic algorithm. It's way more like a giant toolbox, and each tool is custom-built for a specific kind of job. So today, we're going to pull out 3 of the most important tools from that box and see what kind of problems they help us crack. All right, let's start with maybe the most common problem we ask machines to solve: sorting. It's all about looking at something new and figuring out, okay, which bucket does this go in? In the lingo, this is called classification. The whole goal is to teach a computer to make a judgment call. Is this email spam or not spam? Is this picture a cat or a dog? You show it thousands of examples, and eventually it learns the rules to make the right call on its own. So how does it actually learn those rules? Well, one of the most intuitive ways is to basically teach the machine to play a game of 20 questions. It learns to ask a series of really simple questions to slice and dice the possibilities until it lands on the right answer. This method, it's called a decision tree. Let's see how this plays out. Say we want a machine to predict if you can ski somewhere. It might start by asking a really broad question, like, okay, are we in the northern half of the planet? If the answer is yes, it follows that branch and asks the next question. All right, is it wintertime? If the answer is yes again, boom, the model predicts you can probably ski. It's just a path of simple yes or no questions that leads to a surprisingly smart conclusion. And this simple idea, it gets at the heart of so many sorting algorithms. Whether it's a decision tree or something way more complex, the fundamental goal is often the same. Just find the best possible dividing line that cleanly separates one group from the other. Okay, on to our second big problem. Sorting is awesome when you already know the categories, like spam or not spam. But what happens when you don't? What if you just have a giant, messy pile of data and you need the machine to find the natural groups hiding inside it for you? And this can be a really high-stakes question. Imagine a brand new jet engine rolls off the assembly line. You need to know, is this one just like all the other normal ones? Or is it a dangerous outlier, an anomaly? You don't have a label for weird. You just have a mountain of sensor data. You need the machine to find the pattern for you. This, my friends, is called clustering. And here's the key difference. Unlike with classification, there are no right answers to start with. We aren't telling the machine what to look for. We're just handing it the data and saying, hey, figure it out. Tell me which of these things belong together. One really popular way to do this is called k-means. And the process is actually kind of beautiful. First, the machine just plops down a few random guesses for the center of each group. Then it looks at every single data point and assigns it to whichever center is closest. Next, it moves each center to the average spot of all the points it just collected. And then it just does it again, and again, and again. Assign and update, until the groups stop changing. And just like that, you get order out of chaos. Okay, so we've covered sorting things and finding groups. But what about making a whole sequence of smart decisions, one after the other? Well, that brings us to our third and final problem: learning a strategy through pure trial and error. Let's go all the way back to our Mars lander. It can't just sort something. To land safely, it has to pull off a perfect sequence of actions in a totally unpredictable environment. Fire the thrusters, pop the parachute, adjust the angle, one wrong move, and it's all over. It doesn't just need a label, it needs a strategy. This is the world of reinforcement learning. And to get it, we just need to know 3 key ideas. First, our machine, let's call it the agent, is always in a state. That's just a fancy word for its current situation, like its location on a map. From any state, it can take an action, like move north or south. And here's the key part. After every single action, it gets a reward. Think of it like a score, plus 10 points for reaching the goal, minus 1 point for bumping into a wall.
So the whole point, the entire goal, is for the machine to learn a strategy, they call it a policy, that tells it the absolute best action to take from any state to get the highest possible score in the long run. It learns this not because we program it, but because it tries things millions of times, fails a lot, and slowly figures out which actions lead to the biggest rewards.
Okay, so we've looked at 3 totally different playbooks for 3 totally different kinds of problems. Let's step back for a second and see how this all fits together into the bigger picture.
So we've seen that machines can learn to sort things into buckets, right? That's classification. They can find patterns we never knew existed in our data. That's clustering. And they can learn how to master a game or a task by figuring out the best sequence of actions. And that's reinforcement learning. And these are not just some abstract academic ideas. No way. Sorting, grouping, and strategizing, these are the absolute fundamental building blocks behind the AI that recommends movies on Netflix, that filters spam out of your inbox, and that helps navigate your car. It's the core of how machines are learning to solve our problems.
Which kind of leaves us with one last huge question. For all of human history, we've been the only problem solvers on this planet. Now, for the first time, we're building tools that can learn to solve problems for us and with us. So the real question going forward isn't just how they learn, but what truly important problems we should ask them to solve next.